E-Dek Manufacturing was established in Johannesburg in 2001. The company's main purpose is to develop and manufacture innovative packaging platforms, primarily for the logistic and transport industries, by combining steel and plastic. From this, the E-Dek pallet platform evolved, which has since been patented, trademarked and registered in the name of E-Dek Investments Pty Limited, the intellectual property company in the group. Despite some disadvantages, internationally, timber is traditionally used to manufacture pallets. However, owing to ecological factors, including the issue of rainforest deforestation and the competition for water between plantations, human and animal usage, the use of timber in industry has become a contentious issue. Plastic is a potential replacement for timber, but the material's mechanical properties are affected by changes in temperature, making it structurally unreliable and inadequate at elevated temperatures. Timber's mechanical properties are insufficient as they are affected by humidity and abuse, as most users experience. The problem with using timber is twofold: its final disposal and the length of recycling time, as the lifespan of a harvestable tree is a minimum of 15 years. This has led to the concept and design of a light, high-tensile primary steel section, combined with plastic, with steel supplying the strength and plastic the coverage. To minimize the use of plastic, finite element analysis was performed to ensure optimum strength and rigidity in the required plane, and flexibility in its application at minimum tooling cost. The clip-in design ensures easy assembly and cost-efficient load distribution. Different grades of plastic, all fully recyclable, can be used to accommodate various applications. Furthermore, the top surface can be easily customized to suit any function by using solid, slotted, holed, and ribbed formats. A comparative test conforming to ISO standard 8611 was carried out at the South African Bureau of Standards in Pretoria. Timber was loaded to 7.8 kilonewtons, about 780 kilograms. The steel pallet was tested at 44.3 kilonewtons, equivalent to 4,400 kilograms or 4.4 tons. Steel characteristically yields before it ultimately fractures. During the test, critical failure was not achieved, as can be seen by its reverting to its original shape and position. Both inclined plane tests and shear tests simulate a forklift impacting with a leader board of a pallet, testing its fasteners, strength and efficiency. The load test on the timber pallet was conducted using a load of 180 kilograms, causing it to fail. The steel pallet, by comparison, at double the load, that is 360 kilograms, still showed no sign of damage. The steel pallet outperforms any other product due to the relative strength of high tensile steel and the process of welding as a fastening method. It was found that the inclined plane and shear tests were inadequate for attempting to assess a comparison between the relative strength of steel and timber. For this reason, we applied the principles of the IZOD impact test in devising an effective leaderboard test. This assessment involved raising a mass of 175 kilograms to a relative height of 0.654 meters and, through pendulum action, converting this potential energy into an impact imparted upon the leaderboard across a typical width of a forklift blade. On impact, the leading edge of the steel pallet deformed slightly and dislodged 2 plastic slats. The damage to the leading edge was easily repaired with a hammer, and the dislodged slats quickly replaced. The timber, on the other hand, was irreparably damaged and would need replacement. Pallets are used for lifting boxes, crates, and containers. The traditional wooden boxes such as these are bulky, non-durable, and occupy excessive space. The first generation collapsible crates were designed to fit on wooden pallet bases and were loose components requiring assembly and parts management. The next generation consisted of steel pallets and boxes, forming an ideal platform for all the latest cutting-edge developments in the track and trace or other logistics in supply chain management systems. The lightweight, high-tensile steel profile has successfully been tried and tested in a fleet of 80,000 boxes over a period of 10 years. The maintenance requirement of this fleet was minimal when compared to other tubular steel or timber boxes. The versatility of the E-Dek system in the E-Dek pallet enables it to be cost-effectively incorporated into the design of collapsible crates or boxes. To erect the box is quick and easy. It takes a mere 45 seconds to open 2 boxes and even less time to collapse them. In their closed condition, the boxes remain movable by forklift and subsequently add to warehouse space utilization. In addition to this, the new design achieves a 30% weight reduction over an equivalent lightweight steel box and reduces its stacking height by 38%. With the ever-increasing trend towards containerization of local and international freight, the longevity of reusable packaging platforms is vital. They need to remain functional and strong whilst being used, relocated, and reused over extended periods of time. The E-Dek system is ideal for manufacturing both standardized and non-standardized containers, as well as a range of customized applications such as roll containers and tables. All these benefits, in addition to weight savings, when compared to timber pooling pallets and solid steel boxes, are achieved by using our composite products. Apart from having been tested and approved in accordance with the standards ISO 8611 and ISO TR 10233, E-Dek's pallets have been certified for food packaging in terms of European safety regulations. E-Dek, innovative packaging platforms offering you the best cost to strength to weight ratio.